With the recent popularity of GenAI and agentic workflows, I wanted to have a way of running these similar things on my self-hosted Cube home lab powered by Raspberry Pi and Kubernetes. I've talked about this infrastructure in other videos as well, so feel free to check them out. In this video, I'm going to be showcasing 3 tools which are going to help me achieve this. The first one is going to be a way to access or interact with LLMs using APIs. The second one is going to be more of a workflow orchestrator, which will help me use this API in workflows for various use cases. And then the third one is going to be a chat interface, which is going to provide me using the same LLMs. You're not going to be using LLMs using APIs all the time. For example, on ChatGPT, you have a very familiar web interface where you go ahead and type out your prompt and then get a response back from the LLM. That's what the third tool does. Let's see how these are deployed on my self-hosted infrastructure. I'm using Kubernetes, so all of these are deployed as Helm charts, so it should be fairly similar in your infrastructure as well. So let's get started. Let's take a look at the first tool here. This is Ollama. So this is going to help you run LLMs exposed as APIs on your local machine or Kubernetes. In my case, I'm running it on Kubernetes as Helm charts. Since I'm on my Linux machine here, I can check on my cluster directly, so all the nodes are available. If you want to run this on your local machine, however, you can download it directly from the website, and it also lets you run through Docker. So those are some potential options you can consider before trying it out on something like a Kubernetes cluster. One requirement for this to actually work in your cluster well would be a node which has a GPU. So this machine which I'm running things on does have it, but to get it to work, you have to install the NVIDIA GPU operator. Ignore my typos there, but yeah, this one. This is also a Helm chart, so again, this is fairly easy to set up. I had most of the drivers installed on my machine already, but this also has options to run something called as a feature discovery. So it will figure out which nodes have GPU and then install the drivers on those nodes. And you can also define if you don't want the GPU operator to be installed on specific nodes. So all of that is available. And if you want to take a look at the code here, all of that is available on my GitHub. So I'll quickly show you that as well. So this is the cluster resources molecule, and then here in my TF vars there is NVIDIA. So this is it. That's the GPU operator. And if I show you the config, which is GPU operator. Oh, looks like I didn't configure anything. It worked right out of the box. Otherwise, you'll see something like a values YAML file, which isn't here. So that means everything just automatically worked without changing any of the values. So that's the prerequisite, the NVIDIA GPU operator. Once you have that installed, you can use something like this. This is the Ollama Helm chart that I'm using to get it up and running. I also modified the values file. So if I show you this one, this will have a place where you can define the models that you want to pull. So I have LLaMA 3.2 vision and also LLaMA 3.2. I used the vision one for Payobill's OCR integration, which is a different video. So I'll show you that in that video. But you can specify which models you want to pull. And then at the bottom here, you'll see that the GPU by default is not enabled. So if you just install Ollama as Helm chart, things will run, but they will run on the CPU, so that's going to be very difficult to manage. That's not the case for Mac OS, however, because Mac OS, the GPU is integrated directly, so you don't need to worry about anything. On Linux, especially on Kubernetes, you enable your GPU integration, and then if I just set type to NVIDIA, everything just worked, so I don't really care about these other values. These are the defaults themselves, just work. I don't have a MIG device, so I ignored all of this, but what I did do is shard the GPU to work with time slicing. So what that means is the problem that happened was because I have just one GPU. At this point, that's not a big problem. What happened is, because I just have one GPU, Ollama, as soon as it runs, it consumes, it says that it's using the GPU, and none of the other workloads will be able to use the GPU. The problem here is if you want to run things on a scale, so for example, if you have 3 replicas of Ollama, each of them would require a GPU resource. So the way to do it with just one GPU, which I have, is to time slice the GPU into the number of workloads that are going to be using it. The problem would be, obviously, they will have less slice of the compute time. But again, this is just a way to get things working when you have multiple workloads trying to get to the same GPU. Let's start with the Ollama's workloads here. So if I go to Ollama namespace, this is the only pod that's running here. Obviously, if you want to run this on production, ideally you want to have multiple replicas. I've not configured that yet, but you should do that if you're running things on prod. This is where you can see all your logs. This is the version of Ollama 0.9.4 is what I was using when I installed it. That was the latest when I installed it. So let's do one thing. Let's go to services, and then just let's do a port forward on that. So let's do get services on Ollama, and then since it's running on 11434, let's do a port forward on that. Just to separate the port from the one that's running on my local port, I'll do 11435. Oh my bad, forgot to write the name of the service. So that's that. So now 11435 is where I can access Ollama. So if I run Ollama PS on the Ollama running on the cluster, you can see 3.2 vision is what's running, and it's consuming 41% CPU and 59% GPU, and then it's around 12 gigabytes. So it does require a lot of resources for sure. But if you're running some things like SLMs or very specific smaller language models, you should be very alright with moderate hardware. I think there are some which are optimized for CPU as well. So explore models on Ollama's website, and I think now you can also run Hugging Face model directly on Ollama. So good thing to explore. Let's use curl to use the Ollama model now. So as you can see, I can just say hi, and I think I can turn off streaming, to be honest. Stream false. And then I guess also do a JQ. Oh, I don't have JQ, that's weird. Okay. So that's the response. How can I assist you today? And this is how you would probably use Ollama as an API directly if you wanted. I don't know, give me a list of the first 3 prime numbers. Let's see if it starts with 1 or 2. I don't know. Oh, it started with 2, 3, and 5. It's good. So that's how you have access to LLMs running on your Kubernetes cluster. The second tool I wanted to show you was n8n. It's an open source workflow automation platform, and it lets you create these sorts of workflows on your Kubernetes cluster or any sort of infrastructure available. They also have PaaS or other SaaS versions available for this. So you can do it on a deployed instance. I don't have to worry about infra if you want to do it that way. Alright, so let's take a look at the workloads needed to get n8n working. So these are the 2 things. It needs a database to store things, and then the n8n workload itself. Again, I'm running everything as a single replica. Don't do it on your prod, have multiple replicas running. And then good backup strategies for Postgres. I'll cover that in other videos in terms of what backup I am using. But these are the 2 main workloads. So similarly, we can do a port forward on n8n. So that's on the homelab n8n namespace, and then you can expose this one. Let's do it on 8082. That's what I usually use. Just wait for that to start up. So that's there. Now if you go to 8082, should be able to log in. So this is a workflow. For example, you have various types of nodes you can create. As you can see, this is very intuitive and no code based. So you create these little nodes and connect them, and then that's how your workflow gets created. So for example, you have ways to trigger the workflow. I have one that schedules it every minute, and then also there's a test schedule where I can just do a click and then it runs the workflow. So all of that is available. So what this does is it goes to NoCoDB, which is my self-hosted no-code database platform. There's a video on this as well on the Cube homelab series. So take a look at that. So gets one of the transactions in case it has a receipt, which is an image, gets that as well, and then readies this GenAI prompt. So this is the prompt, and then this is where it'll add the transaction receipt and the transaction text that was available from the SMS that I received whenever I make a transaction. It then makes a call to this AI agent. If you look at the Ollama chat model, this is making the same, making use of the same Ollama deployed on the cluster, and then also then parses that transaction using. So whatever JSON is received, sometimes the model will output garbage, like it will try to return Python code instead of JSON, even though the prompt is pretty clear. Not sure why. I'm working on fixing all of that. So I try to parse data from it. If it still fails, return an error JSON object. So at the end of it all, it gets one either success or a failure JSON object. And then that is what's updated in the same row in NoCoDB. So that's how this workflow is built. There are other workflows as well. Let's take a look at this one. For example, this sends out a notification to Notion. So on Notion, what I've done is I have a table which whenever there's a new entry on that table, I get a push notification on my mobile phone. So multiple ways to again trigger this. One is a webhook. One is just a test trigger. There's an input guard, so you have to pass the notification message in the payload of whoever is triggering this workflow. And then what that does is then sends out a message or sends out an HTTP call to api.notion.com, and all the credentials and everything are set up here. So all these have been set up, and I can also show you a few executions. So let's take a look at this execution. For example, this was a couple of minutes back. So let's see what the message was. Made a transaction, this one. I'm parsing all historical data, so you can see these are older transactions. This didn't have an image, so it skipped it. Let's see what the generated prompt was. So I pasted the transaction text here. This is the JSON I want in case things fails. This is the error object I want with the detailed message. And then at the end, let's see what the result that was updated was. So it was able to parse amount, merchant, the time, and the currency, and few notes as well, and then also tags from that transaction's text. This didn't have a receipt, but if it had, it would have made use of LLaMA's 3.2 vision model to do an OCR, figure out more details. But as you can see, most of these details can be passed from the transaction text itself. And as you can see here, a new workflow just started. So those are two tools that I'm using for GenAI. The third one is slightly different. Let's get into the cluster again, and I want to show you a couple of more workloads. So let's go to the full pod view, and here if I search for open web, so this is the third tool that I wanted to show you. Open WebUI is a way to use your LLMs using a chat interface directly from an Ollama instance, for example, and everything is self-hosted. Again, let's again, this has a couple of things deployed. So one is pipelines and WebUI. These are deployed through the Helm chart again. So I've not configured anything apart from passing in the environment variable, which points to the right internal SVC cluster local address of Ollama. Let's move forward this one. So here, as you can see, we're going to be doing it on 80, and then the service is open-webui from homelab open-webui. So now it's running on 8080. So let's refresh this. As you can see, it has the same list of models available. So here, as you can see, this UI is very familiar, right? This looks exactly like ChatGPT, and it has these models available. This model is still running, so we can use that. So let's do. So as you can see, this is the response that it gave. It's hitting Ollama API view incomplete, but obviously you can tell. And as you can see, the responses aren't as fast as I wanted it to be. So this is what I got. So those were the 3 tools I wanted to cover in this video. Obviously, there are a lot more things to explore, and I'm excited to see what I can do with GenAI on my self-hosted infra. One of the ideas that I mentioned before is to make use of these tools on my PO Builds project. So I'm going to be covering more topics on the Beyond Full Stack Engineering series. It's a series about expanding my skill set into work more on front end, back end, cloud, infra, and now GenAI as well. So if you have topics on any of these that you want me to cover, leave a comment on this video so I can cover that in one of my future videos. See you in the next one. Bye.